Okay. Alright, so welcome to this recap. And actually, yeah, okay, you're welcome. So, we're going to, like, we just continue from where we left off in the last video. So, that is to resolve this equation, this differential equation of order 1, to resolve it in order to get to this point. Okay, so we can determine our terminal velocity at time 0, 2, 3, 4, 5, 1. Okay, so like we said in the previous video, to do that we use we make use of the method of integrating factor. Okay, so using the method of integrating factor, okay, which is IF. Now, this is how we go about that. So, for the method of integrating factor, we use the integrating factor of this equation to multiply through. Now, in the method of integrating factor, this part is considered as P, and our integrating factor comes in the form of exponential integral P dx. Yeah, so our integrating factor comes in this form, and this part is regarded as P. Okay, now let me just stop here and say this quickly. Note that we've said this over and over again, that this video series is just a recap of what was done in class. Okay, now integrating factor. Okay, how do I, if you are thinking like to go into this topic, integrating factor, method of integrating factor, that's to resolve or solve differential equations. If you are thinking, okay, how do I go about that? There are a lot of videos on YouTube. Okay, so you can just, or maybe I will leave a link to one video. Okay, and the guy is super good. Okay, the organic chemistry tutor. As in, the guy is super good. Okay, and there are a lot of others online, so you can just check that out. However, in solving this differential equation using integrating factor, I'm going to follow the process and explain step by step. Okay, so you can maybe download videos on just integrating factor and see what I'm doing here, but I'll explain I'll explain step by step. Okay, so let's continue. Now, what you do, you take this value here. Okay, you take what you have here and then you express it in this form. Note that this P here, the P here represents C over N, and then the X, of course, in our normal differentiation, we have dy over dx, but in this case we have dt here, meaning this point will be dt, not the x. Okay, so our integrating factor will come in this form. We'll have it like this: c over n dt. We'll have it in this form. And if you take the integral of cn with respect to t, if you take the integral of that, cm is a constant, so cm, cancel out please. Cm is a constant, so you take the integral of dt. So integral dt will give you what? T. Okay, So that means we'll now have E, we'll have E raised to the power C over M T. So this is our integrating factor. This is our integrating factor. Okay? That's our integrating factor. Let me wipe out the rest, or should I leave them? Let them be. Alright. So that's our integrating factor there. Okay? Just wipe this out. This is our integrating factor. Alright. Are we together now? So, like I said, we'll use this integrating factor. We'll use the integrating factor to multiply equation I. Now, what do we have here in equation I? We have this. So when we use this integrating factor, e raised to the power c m t, what we use to multiply that, we are going to have this. Excuse me. Okay, so e c m t, then we have dv dt, right? Then plus multiply this also. What do we have there? We have c over mv, then equals excuse me, and then g. Good. So this is what we have now. At this point, we are going to use the idea of product rule in differentiation. Again, you can check out videos on, and just type on YouTube. YouTube may a lot of things there. So you just type on YouTube the product rule, and you see videos to explain that, so you understand what I want to do now. However, I've explained what I want to do now. So using from the product rule, v du and u dv. Okay, now from the product rule, think of from the product. Okay, let me not spend time to explain that, but just using the idea of product rule. From the idea of product rule, when we have something like this, u and v. Okay, this v here is a different view. It's a different v entirely, and the u is a different u. From the idea of product rule, if you want to differentiate this v and u and v, what you do is you hold one of them. For example, you hold the u. Okay, just keep the u and differentiate. Excuse me. Keep u, then differentiate v. So you have the v. Okay, and then you hold plus. Then you hold v. You hold v. Excuse me. You hold v. You hold v. For right now. You hold v and you differentiate u. This is the product rule. This thing here, this is how the product rule looks like. When you have two, you differentiate, you hold one, you differentiate the other. You hold the other and you differentiate the first one you held. Now, looking at this part, this part, it is in this form. It is in this form of the product rule. Can you see that? So that means at first you have this u. Now let's say the u can represent these parts. Okay, and you can see at this point it is not differentiated, but v is differentiated. V now of course represent v here, is differentiated here. But in this case, of course, our dv will be with respect to something, okay? So that's not the main thing here, okay? So in the plus, the same plus sign, what we have here, this time we kept v and we differentiated these other parts. Yes, we did, because if we differentiate this, the power will come down to multiply. So you have this. So all we are saying is that this expression here is the same as this. It therefore means, let me put this d here, okay? So differentiating this means you get this. Now, it therefore means this expression, you just have to take this and take this, settled. Okay, let me take out all those events. Okay, let me take out all this thing. So you can pause the video and check out what I just said. Okay, or take the video back and check out what I just said. So to apply that, it simply means that this expression is the same thing as saying differential of exponential cmt multiplied by v all over dt equals what we have at this other side remains the same. Good. Alright, so I guess you are following so far. So thank God this is a video, you can pause, take back, move forward like that. So with that being said, now we can cross multiply so that we have this dt at this other side. So if we do that, we'll have the take this closer, get closer, and you have EC over MT, and you have V here equals what? EC over MT, and you have G here, then you now have dt this time. Good. This d, yeah, it's correct. Okay, now upon integration, if we integrate this, so upon integration, we are going to have something. So if we integrate this, it will give let me just copy this whole thing first. Let me copy this whole thing. So if we integrate this, so upon integration, we integrate this, we are going to have, of course, integration and differentiation, of course, and that will leave us with what we have inside the brackets. V equals, now G is a constant in this case, because in this model, G represents acceleration due to gravity, so it's a constant. So G comes out, we are going to have G this way, and now integrate. So we integrate this with respect to t, and when we do this, we are going to end, or we are going to get where are we? We are going to get TV equals, when we integrate this part now, it will give us g. Now when we integrate this, we just take the reciprocal of this, okay, and the rest things remain the same. We take the reciprocal of this and multiply by what we are integrating, and the rest things remain the same. So it will give us reciprocal of c over m is m over c, so that will be m all over c multiplied by same thing. Okay, that's t there, plus the constant of integration. I would have made use of c, which is constant of integration, but since we already have c in our expression equation, I decided to make it k. You can use any other thing, but okay. So yes, now with that being said, so since we have that now, then notice that we are looking for v, terminal velocity. So so what we can do here is this: make v subject formula. But before we do that, okay, let me do that. So we make v subject of the formula. Okay, make v subject formula. Good. So we make v subject formula by, of course, dividing through by this guy. So when we divide through by this, when we divide through by this, okay, it's going to cancel out there, and we're going to have, sorry, I need it back. We'll divide through by this, it's going to cancel out there, and it's going to be here, and we'll bring it here, it will cancel out this other guy. So we'll bring it here, okay, just like you divide through now. Delete okay, alright. So when we divide through, there will be no e raised to power whatever here, and there will be no e raised to power whatever here, but we'll have e raised to power this here. So of course our division line, okay, but if we do that, we can bring this guy using the considering the laws of indices. We can bring it up here, which will give us, let me make this whole thing neat, please. Let me just write this whole thing again, which will give us plus e raised to power negative c m t multiplied by k, equation ii. Good. Alright, so now when we have this, we are going to apply the conditions at, that's initial conditions, at v equals 0 and at t equals 0. So we can now say at v equals 0 and t equals 0. So at these conditions, we apply these conditions so we know what k is. So at these conditions now, let's solve for k and bring the value of k back into equation ii. Okay, so at this point now, that means where we have v, we are going to have 0 there. So this will be so this will be 0, that will be 0, and what again, another 0. This k here, t here will be 0, this will be 0, and of course when 0 multiply this, it will be 0, of course, and anything with the power of 0 will give us 1, so everything here will end up as 1. So 1 multiplied by k, we will have just everything here will just be k. Alright, so this will now leave us, and this, so when everything here ends up as k, we'll now have this plus k. Then we'll move this to the other side to give us negative all this is equals value of k. So we can just write this as straightforward, saying k equals negative g m over c. Okay, this is for k. All right, now we'll bring the value of k back into equation ii, substitute into equation ii. So let's substitute now. So this will be where we have k now. We'll now have negative gm over c. So I'll multiply by this. So this will result in excuse me. Alright, so this will result in having a negative sign here, because when this multiply, we'll have a negative sign here, and then of course gm over c. Now we can see that gm is common to both sides, so we can substitute out, it's my gm larger, we can substitute out gm into we can factor out gm. Okay, we can factor out gm, and we are going to factor out gm now. So once we factor out gm, we are going to have just good. Now when we factor out gm, we are going to have v equals gm. Let me put this under better. When we factor out gm, we are going to have gm, not just gm over c, gm, then we'll have 1 minus exponential t. This is negative, okay, negative, yeah, this is what we're going to have. So look at it to be sure. Okay, we'll factor out gm from here, we're going to have 1 left, that's the 1, then a negative sign. Factor out gm from here, we have this part left, and that is it. So of course this v is with respect, v changes with respect to t. So instead of having v there, we can have, instead of having v there, we can write it as v of t equals gm over c over c 1 minus e minus c. Boy, what's happening? C over m multiplied by t. Yeah, and that's it. So this is our final answer. Okay, that's a final answer. That's a final answer. Okay, so yeah. Now just so just a little recap on what we've done. Yeah, this is it, correct. So just a little recap on what we have done. We used the method of integrating factor. Okay. Oh boy. We applied the method of integrating factor. Okay. And then we applied the boundary conditions. That's the initial conditions. And that's it too.